Talking about another periodic trend, electronegativity, it is the ability of an atom to attract the electron towards itself in a chemical bond. So, whenever we talk about electronegativity, we are not talking about a single atom. We are talking about a molecule. For example, here, it is HCl. It is the covalent bond between these two, hydrogen and chlorine. As here values of electronegativity are written, hydrogen has electronegativity 2.2 and chlorine has 3.1. As values are showing, chlorine is more electronegative than hydrogen. That's why chlorine pull the electron more toward itself than hydrogen. Similarly, when we talk about water, it is H2O now. So it has oxygen and two hydrogens here are bonded. Just like we know that कि जो oxygen है, it has valence electron 6, means 2 here, and 1 here, which is actually bonded with that hydrogen, and this is the valence electron of hydrogen, and here 1 is which is bonded with the another hydrogen. So it has 6 valence electrons, and it has the hydrogen, they have only 1 electron in the valence shell. So these electrons, they are more towards the oxygen than towards the hydrogen. Why? Because oxygen is more electronegative than hydrogen, as the values are written here. The oxygen has the electronegativity 3.44 and hydrogen have 2.2. So that's why the electronegativity of oxygen is more than that of hydrogen. Talking about the periodic trends in the electronegativity values, as we move from top to bottom in a group, the electronegativity decreases. Why? As we have talked about the this situation, that when we move from top to bottom in a group, there is an increase in the number of shell. For example, here hydrogen to lithium to sodium. Talking about sodium, it has 11 electrons, 2 in the first shell, and 8 in the second shell, and 1 in the outermost shell. So when we move from sodium to potassium, it has 19 electrons, which means that 8 electrons यहाँ पर complete होंगे and another shell is added, just like this one. It's 8 and 8 16, 17 18, and another shell added in case of potassium अगर हम बात करें. So similar goes for all the elements as you move from top to bottom. So what happens? More and more inner electrons are added, and these inner electrons, they shield the outermost electrons from the from this nucleus, from the attraction of this nucleus. So it is very easy to remove that outermost electron. For example, cesium की बात करें तो it has the same structure, the inner electrons and that one valence electron, and this one valence electron, it is shielded by these inner electrons. Same charges repel each other now. So that's why it is very easy to remove that valence electron. So we can say that they have less attraction towards the electrons as you move from top to bottom. That's why electronegativity decreases as we move from top to bottom. But when we move from left to right in a period, the electronegativity increases. The value of electronegativity increases. Just like this one, as you move from sodium to magnesium to aluminium to silicon in that line. So when we move from left to right, electronegativity जो है वो increase कर रही है. It is very easy for the sodium to give its electron, its outermost electron. Similar goes for magnesium, then aluminium. But when we talk about chlorine, it is more comfortable at gaining electron, or it only gains electron. Just like we saw the structure of NaCl, we know that Na is actually, it has a positive charge, negative charge. Why? It is giving the electron to chlorine, and it is taking the electron from that sodium. Chlorine is. So that's why the electronegativity value, it actually increases as we move from left to right. There is a scale known as the Polling scale, which is designed by this person to calculate the values of electronegativity. And according to this scale, fluorine is the most electronegative element in the periodic tables. So this is a short video which is all about electronegativity, and thanks for watching.